Hello, in this video, I want to talk about how to fit linear mixed models using the R package nlme for some additional analysis. So first, let's load in the libraries. So we need nlme, ggplot2, lattice, and performance. Set random seed and create 50 subjects and 5 time points for each subject ID and the time, intercept, slope, create 2 covariates, put them into dependent variable, and then create the longitudinal data set. It looked like this. Okay. All right. To fit LME linear mixed model using nlme, we use the R function LME in nlme. And this is the syntax. Basically, we make sure we're using maximum likelihood estimate because we're going to compute the AIC values. Okay. And we're using the AR1 correlation structure with random intercept and random slope. Okay, so here, let's fit it. And this is the summary. You can see it has the basic information about the model. So give you, it already computed the AIC and BIC value. Give you the random effects formula. Give you the, as in correlation, structure estimates, and then give you the fixed effects, the coefficient, including p-values. Okay. And then there's also within group residuals, and it tells you number of observations and number of groups. Okay, so these are the basic model information we can get from LME. But of course, in this video, I want to show you a little bit more. So first, we can do likelihood ratio test for model selection for nested model. For example, if we just fit Y-tiered1, just the intercept only model, we call it the null model. And then we can just use the ANOVA LM and LMM underscore null. And this gave us the likelihood ratio statistic. So P is much less than 0.05. That's saying, adding time covariate 1, covariate 2 made the model much better than the intercept only model. Okay. The second thing we want to do is to get the intervals, confidence intervals for all the effects. You can see it has confidence intervals for the fixed effects, and then random effects and correlation structures. So there's a lot of confidence interval computed. Okay. And also we can look into the model performance metrics and performance package. One is using the check model function. It will generate these 4 residual plots, allow you to check the linearity and collinearity, the variance inflation factor, and also normality of residuals, and also normality, and also histogram of residuals. So from these 4 plots, our model looks pretty good. And also we can use this R square, R2, to calculate the R squared value. So here's there are 2 of them. One is called the conditional R square and the marginal R square. Okay, the conditional R squared is actually the variance explained by both fixed effects and random effects. Okay, the marginal R squared is the variance explained by only the fixed effects. Okay, so here you can see the conditional R squared is almost like 97%. Very, very good. Okay. Marginal R squared is 81%. 0.5%, also pretty good. Okay. And of course, we can get other model fit statistics. We can bring them out. You can see we get AIC, BIC, we already know what that means, and R squared, conditional, and the marginal. And I just want to explain a little bit about the other parameters. The AICC is the corrected AIC value, so I did a little bit of adjustment to the AIC value. And this is really suitable for small sample size problems. The RMSE is the root mean squared errors. This is really measures how good is the model predicted values compared to the observed values. Okay, and square the residuals and calculate the mean square. Okay. And ICC is the intercluster correlation. It is actually the variance in Y due to differences between subjects as compared to difference within the subjects. Okay, and it's good because our package performance automatically calculate ICC values. Sometimes when you have a pilot data set, you can fit linear mixed models, you can get the ICC estimate, and then you can use that to plan future studies. Okay, and the sigma is the residual standard deviation. Just make sure you understand that. Okay, so if you really want to check the variance inflation factor, there's called the check underscore collinearity, and we'll calculate the VIF values. And you can see all three VIF are like a 1, so perfectly no collinearity. Okay, but this we know this is a simulated data set, so we cheated. Okay. All right, and you can do some additional residual analysis. For example, check distribution. This tells you distribution probability. Basically, 75% of the points are following normal distribution, so it's pretty good. And predicted distribution of response, now it's down to 12%, which is not good. And the log normal is 47%. So the data distribution may need some work, okay, for the normality of the residuals. Okay. You can check outliers. It gives you some qualitative statements, and basically no outlier detected for our model. And you can also check heterostaticity. So basically, it's also it seems the equivariance assumption is relatively good. And also, there are different residuals. You can get the raw residuals, the Pearson residuals, and the standardized residual. There's 3 types. Okay, you just have to specify type equal to response, type equal to Pearson, type equal to normalized. And you can say just plot out all these 3 residuals. Also, the QQ norm. So yeah, so this looks pretty good. They're all pretty close. Almost all of the data points are within -2 and +2, so that's pretty good. And we can compute the random effects, the blobs. So we can calculate them and we can also plot them. Okay. And the random effects, these blobs are actually very useful. We're not going to expand our discussion here. But for example, you can maybe use the blobs to do a cluster analysis. You can actually group the random sample into different subgroups, okay, because their random effects are more closer to each other, okay. So, and also you can do predictions with new data. Regression models can be used for predictions. Say we create a new data set with just one observations with covariate 1, covariate 2, And then we can just do the prediction using the predict, put the LM object there, new data equal to new data, and have level equal to 0 and 1. So basically whether we want fixed effects so we only got, for this case, we only got the predicted fixed effects. We didn't got the predicted subject level. Okay. And another one available in the nlme package is the argument prediction. So you have to specify which primary predictor you want to generate the prediction against. And you can say level equal to 0. So this is the kind of fixed effects level. So this is the head. And there are two types. One is original, the other is predicted. Okay. And if you want to take a look, it's this object is a data frame with 2,800 observations for variables. But the first variable doesn't look very correct to me. I have not checked these very thoroughly, but here I just want to verify the R commands mentioned in the R documentation for nlme actually work. Okay, so this is the spirit of the how-to videos I'm producing here. Okay, and nlme is a very comprehensive package. If you read its documentation, it has so many subjects in it. And it's almost like a small software. So you may run into bugs here and there, and you can report them or send them to the mailing list of the R users group for feedbacks. All right. Thanks for watching.